All right. Very good. Thank you. Very cool. Well, that was close.
Yeah.
Alrighty. I'm going to do a lot of the live demos. I'm going to just sit down for the most part, if you don't mind. My name is Ray. I'm a developer advocate for the Google Cloud Platform. I'm based in New York. I grew up in California, so I like the weather out here a lot more. And if you have any questions, please, you can reach out to me on Twitter @Stalinism. And if you got specific questions you want to ask on email, my email address is rayt@google.com. So feel free to reach out. One of the things I do is not just to raise awareness about some of the Google technology, but as a developer advocate, my job is really to advocate for the developers. So if you have any questions, if you have any feedback, anything that you need, you want to see in our products or in our open source projects, please let us know. It's one of the most important things that we do. And I've been a Java developer for about 10+ years now. I've been engineering for almost 15 years. So that's why I'm going to the Java user group. That's where my root is. I love Java myself. Aside from technology, I love to travel. This is my maybe third time in Utah, actually. I have to say though, every time I come here, I get a traffic ticket. What? I don't know why, but every time I've been to Arches National Park, Bryce Canyon, Zion. I did that Angels landing hike. That's one of the most beautiful hikes. I also went to all the different ski resorts here, but every time I come here, I get a ticket. So hopefully not today. Yeah, hopefully not today. I love to travel everywhere, and you can see some of my photos on Flickr as well. This is a funny story though. Since you did say that I came to the desert, it's actually not quite a desert for me because that's a real desert out there. I was traveling in China, in northern China, and I had no place to stay for the night. For whatever reason, there's a long story behind why I didn't have a place to stay. But somebody told me that if I go out to the desert and if I hike for about 4 hours, I will be able to find a real oasis, and I can stay there for free. And I was a cheap backpacker at the time. I heard free, and I just went for it. I didn't think twice. But I did have to walk in the desert for about 3 hours and a half. Anyone here hiked in the desert before? A sandy desert? No? Yeah, a few. There's always a few. Walk on the beach. Walk on the beach. Yeah. It's not the same. I just have to say it's not the same. It's not like walking on the beach. Every step you take, you kind of sink a little bit, and you have to pull yourself out. And when somebody tells you, you gotta walk in one direction in the desert for 4 hours, it doesn't matter what's in front of you, you just go that direction, all right? So if there's a sand dune, you just go over it. If there's a spider, whatever, like scorpion, you just don't care, you just go that direction. So it was pretty tedious. It reminds me of, seriously, it reminds me of the Java days where I had to write JEE application. I don't know if anyone here had to do that, but it's kind of tedious. But the end was beautiful. I was able to see the oasis. I stayed there for the night, and it's really, really nice. And that's kind of like how I see my job in one way is to hopefully not having you to have to walk through the desert yourself, but maybe just helicopter drop you into this beautiful place so you can try all the new things. Just a quick show of hands since I'm in a Kubernetes meetup here. I'm assuming everyone here knows Kubernetes already, right? Using Kubernetes, and even many of you. That's awesome. So I'm gonna skip over some of these slides. One thing I do wanna mention here is one of the most eye-opening thing for me when I was using Kubernetes and learning about Kubernetes. The key for me was to not seeing each individual VMs as its own resource anymore, but through the lens of Kubernetes, we are seeing the aggregate of resources together in a single pane of view, right? It's no longer, well, what size of a VM do you need for your application, but it's more of, well, how much capacity do I have in the entire cluster, and how much capacity do you need for your application, and you let Kubernetes schedule it for you, right? So we don't deal with individual machine as a pet anymore, we just go through Kubernetes as a single pane of view. That for me was the biggest eye-opening moment for myself. And I'm gonna come back to this later when we go into Federation, because this is exactly the same concept that's being applied at a higher level. I'm going to show a little demo and hopefully successfully build a federation cluster as we go through the demo. But first, for my local development environment, I'm going to run my application in Minikube. I'm going to show just a little bit how I can take that application and propagate it all the way out to a federated cluster that's going to be spanned across 2 different regions. And we'll see how that's different, okay, in terms of how we use Kubernetes. Okay. So here we go. Hopefully this is all going to work. Let me see here. I have Minikube up and running, I hope. There we go, it's running. Let me get a visualization tool up and running as well. So we're going to see what is my current context. Minikube, that's good. So let me, I have a visualization tool that I can use to kind of see what's running inside. So I can go to localhost 8080 static. Okay. All right, that's not bad. So I actually do have my application already deployed in Minikube. There's 2 containers. There's a front end and a back end. Now, this is not a typical front-end, back-end application where the front-end actually talks to the back-end through an external IP address. In this application, the front-end is really just a static site that's just making a call out to the HTTP API on the back-end. Okay, so let me just show you a little bit of how that works. If I go to Minikube service, hello world front-end, hopefully I'll be, oh hey, what is going on here? All right. Let me see here. Still get paths. And let me get the service. Oh, everything's there. All right. And there's the no port of the 30271. All right. So let me see if I can just go there directly. Ah, there we go. Whew, that was close. Live demos. You never know if something's going to work. All right. Okay. So I think that's the back end. Because I just built in the front end in there so I can test it. So here's the front end. So it's a little simple application where you press the button and it's going to hit something in the back end. And this is not working so well right now. That's only because, let me go to inspection. If I go into, I'm going to pop this out in a second. Network, refresh. When I click on the button, it's actually making an AJAX call out to the API next endpoint. And so in order for this to work, I actually have to use an ingress, right, to front my services with a public URL. So I can do that pretty easily. I'm going to apply this into my context of Minikube. Minikube and apply F and button ingress. So I should be able to get that done pretty quickly. And if I get my ingress up and running, here's my IP address, and I should be able to go there. Oh, not bad. All right. And now, if I click on this button, right, it's able to communicate with the backend only because I'm putting the right URL mapping, right? So by using an ingress, I'm able to map my API next to the backend service port. Okay, pretty straightforward. That's what I have running locally. And then we can do many things with it now, right? We can actually just export potentially some of these configuration out. In Kubernetes, right, we can use the kubectl command line. I'm a little lazy, so I don't start with the YAML file directly. I kind of just run things and make it work. And then I do the export, right? So I can go ahead and get my services with the export. So for example, get SPC, button, masher front end, and button, masher back end. Do the export flag, output to YAML, right? And I can pipe this to my services.yaml. Right? And I can do very similar things for my deployment. I'm gonna get this directly out of my Minikube cluster as well. And let me do exactly the same thing. Okay. Right? So I'm going to do deployments here. Right? So once I have this YAML file, then I can decide where I actually want to deploy it. Now, we all know we can actually go and deploy this YAML file now to a cluster of machines, right? Doesn't matter how many machines you have, you can just say kubectl apply to another cluster. It doesn't matter what it's running, AWS, Google Cloud, Azure, it will just go ahead and deploy. But that's just to one cluster. Now, here's the thing I learned a little bit about talking to some of the users and customers I work with. Like, some people tell me that they're using containers. I'm like, okay, how are you using containers? Or we're using Docker, and I'm using Docker command lines to build it. How do you deploy it? We SSH into the machines individually, and we say Docker run, right? Now, Kubernetes, of course, doesn't need you to do that anymore. But now the question is, what if you have multiple clusters? What if you have multiple clusters that need to work together to provide potentially a multi-regional or a highly available deployment, right? And there are actually quite a few use cases for it. I have talked to people who really want to use multiple clusters, potentially in different cloud environments or in the cloud and on-prem, and they want to federate, they want to work together, they want to manage both clusters the same way, right? Rather than use kubectl and set the context over time to figure out which cluster to deploy to, that's almost like, SSHing to the machine and do the Docker run, right? So how do we actually manage both clusters together? And there are some benefits to it. You could potentially have, cluster running in Asia, a cluster running in the US. In case one region goes down, then you can redirect all of your traffic to the other one. But it's a little bit more complicated than that because you do need other ways to load balance your load across multiple clusters, right? But there are little other things that catches people off guard, but Kubernetes Federation cannot think about this ahead of time, which is if you go across providers, if you go across zones, or even if you go across regions, when you communicate, there's a cost associated. The cost is not just how much it costs, but also the latency that's related to it, right? So for example, if you have a service that's in Asia, and you don't have a service running in the US, but everyone's coming into the US cluster, now your application in the US has to always make a call out to Asia, and that's going to be higher latency. You're not going to be able to handle as much load, let alone the cost associated with egress, across zones or across regions. So you have to be aware of that as well. So in Kubernetes with Federation, what we are able to do is, number one, we can manage multiple clusters, again, through a single pane of view. So imagine each individual machine now becomes a mini cluster of some sort, right? We apply the same concept of having a control plane that controls individual machines. We now have a control plane that's a federation control plane that can control multiple clusters. But in addition to that, we also built in something called the cross-cluster load balancing. In Kubernetes, in a single cluster, we're able to do load balancing with cluster IP, right, with the local service IP addresses, or with ingress of some sort. In a federated cluster, we can take that same load balancing concept as a service, but apply what we call a cross-cluster load balancing to it. What that actually means is, if you have a workload that's running in the same cluster as the consumer, we will just go ahead and use it rather than going across region to another cluster. If the backend is not there, then the consumer can still discover the services that's running in another cluster that theoretically is the closest to the consumer. All right, so I'm going to show a little demo of how that actually works. There are other things you have to consider, specifically about Infinity. If you have a workload that needs to consume other services, you kind of want to make sure that the service is closer to your consumers as much as possible. Or if you have multiple clusters, you don't want to manage them individually. You should be able to specify where the workload should be running, which cluster the workload should be running, right? If you launch a job, if you launch like a batch job, right? Maybe you want to say this batch job should only run in Asia, but not in the US. So we're able to do that in Kubernetes Federation as well by applying some annotations to say where the workload should be running, okay? So very high level of how this actually works, and I'm going to just show you exactly how it works in the demo, right? So this is a high level view. We just put in a control plane in front of not the machines anymore, but in front of the cluster. The way that we interacted with the cluster was by using the master node, right? So if you can create a Kubernetes context that points to the master node with the right credentials, well, in a federation control plan, we just need to access, getting those credentials for each of the master nodes, and then we can just control everything through a single API server in this case. Okay, and you can actually federate potentially multiple clusters in different cloud environment. About 2 years ago, when we did the demo first, we actually have done this with the on-prem cluster that was sitting at a keynote stage just right next to where I was. And then we have another cluster in the cloud, and we're able to federate both of them together. That was even before this federation control plan came in, right? Now the federation control plan just made that whole work a whole lot easier to do, all right? So how do we actually do it? Given that you have multiple clusters across multiple regions or zones, whatever, you have to pick one of the cluster as the host. Just like in a single cluster, you have multiple machines, you have to pick one machine as master, right? So same thing in the federation, you have to pick one of the cluster as the host of the federation controller or the federation API. So pick that cluster first. This whole process used to be very manual. I have to go through that once. I don't recommend it for anyone. It's not easy. But now they have a command line utility called kubefed that makes everything a whole lot easier. It actually does a lot of the configuration for you behind the scenes. So number one is you pick the region that you want as the host cluster, and then you need to deploy the federation API server and federation controllers into it. You also need to deploy etcd, for example, into this cluster as well. etcd is used by the master nodes for one cluster, but now we're also using etcd for the federation server also.
So, sorry, Ray.
Yeah.
So are you saying that there's a separate federation etcd cluster?
Yes, right.
So each cluster will have its own etcd cluster, as
Right.
well as a federated etcd cluster.
Only for the host. So
Only for the host.
yeah, only for the federation host. Yeah.
But if you wanted HA, meaning
Yeah, then you gotta deal with that as well. Yeah, yeah. So most of the times we just deploy, if you use kubefed, when we deploy the federation host or the federation servers, they actually create a new namespace in your Kubernetes cluster. It's called the federation systems namespace, and they just deploy the API server, the controller, and etcd into it automatically. Okay. And that will then expose the API server, the federation API server, via a public IP address. And it will also have a credential for you to log in via a cert, for example. And that will ultimately end up in your context, in your Kubernetes context. Okay. So, with that, what that means is you can use the federation control plan just like any other Kubernetes cluster by using the kubectl command line. Right? All the same APIs are also available as well, so you can also make the RESTful requests to the resources that's federation enabled. Okay? Not everything is federation enabled. There are only a subset of resources that you can use and manage directly from the federation. Does that make sense? All right, cool. Once you have the control plane, then you have to register individual clusters into this control plane. The easy way, again, is by using kubefed. You can join the cluster. But the trick here is that you need to have the context that you use to connect to the individual clusters. You need to refer to those contexts, right? And what this command line will do is to take that credential from your context and send it to the federation control plane. And that is the user that the federation controller can use to log in and control the individual clusters. So you do have to kind of think about, well, okay, what user do I want to have access? Well, typically right now just admin, but it depends on what you need to do. Okay. In this context, you also set the server API address as well. But all of these things are all done for you if you use the kubefed command line. Okay. Once you have done that, you're pretty much set to go. There are a few other things that happens behind the scenes. I'll talk about when I go into the demo, but just so you know, once you have the control plan, once you register your cluster, then you can just use kubectl command line against the federation control plane. You can deploy services, deployments, config maps, secrets, and whenever you do that, it's going to go ahead and propagate these configurations to all of the clusters that's under the federation. Okay. If you're deploying a service, we can also configure the DNS for you as well. I'm going to jump into this as well. This is how the cross-load balance, cross-cluster load balancing works. It's actually done by using the DNS. Right? Same thing with the deployment. If you deploy into the control plane, it should theoretically deploy to individual clusters as well. In this case, I got Google Cloud, on-prem, another web services cloud. I don't know what that stands for. All right. All right, so let's see how that works, right? So I should have, I mean, this is the most difficult part of the whole thing, and it's gonna take the most time as well. But let's see. All right, so I'm using Google Cloud Platform, and I'm just gonna show you what I have set up, okay? Right now I have two clusters. I got a cluster in Central, US Central. Where is that, by the way? I have no idea. I don't know where the US Central data center is. Ohio? Okay. All right. Yeah, I have literally no idea who that is at this moment. It's probably Ohio, you're right. And then we have on the EU West as well. So that's just across the pond. So I have two clusters up and running right now. This is, if you never used Google Cloud before, it is by far one of the easiest way for you to provision a cluster. All you have to do is to just click, say where you want to run it, what version you want, how many nodes you need, blah, 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 and then just in the end, click on create, and you just have a cluster. It will take about 5 minutes to create a new cluster, just to bring up the new machine and stuff. That's why I got these two pre-created. And they're running 164. If I want to upgrade it, I can, but I don't want to do this just before my demo. Right? Probably a little risky. I'm a risk taker. I mean, I will walk in the desert by myself, but I will not upgrade my cluster before my talk. All right. It should be pretty straightforward. We manage all of these upgrades for you too. All right. So in my context, let me see here, config, get contexts, and let me see here. I'm gonna grab for kubefed because that's one of my context code. I got the US Central and EU West, right? So the first thing I need to do is to pick one of them as the host. So I'm going to just use kubefed init federation. The host cluster, right? I'm going to use the US Central as the host. If you can see it, now I can zoom in a little bit. Oh, that was not zooming in, was it? There you go. All right, cool. And then here's the important part. To use cross-cluster service discovery, you actually have to be able to connect to a DNS server that you can actually control. And we have different plugins for different DNS providers. There's a Google one, so we have like Google Cloud DNS. I'm pretty sure there's another web services one. And there's one that you can run on-prem. It's called Core DNS. And I'm pretty sure they have a provider too. What this will actually do is, if you ever expose your service and you want cross-cluster load balancing, we will actually go ahead and update the DNS records for you automatically. So you can actually use some of the, you can actually use the DNS name for these kind of lookup. I'll show you exactly what that looks like in a second. And because of that, we need to specify a zone as well. This is basically where all the service DNS names will be updated into this zone. It's going to be suffixed by demo.kubefed.org. It's a real DNS name I have to pay for. All right, so let's try this first. All right, so I'm going to hopefully initialize. This takes a while to say. That's why I'm speaking slowly. Hopefully initialize my federation control plane in about 30 seconds or so. All right, and just so you know, oh shoot. Yeah, that's fine. So I can, for example, if I want to see what's going on, I can go to my host cluster, kubefed central, get ns. That's the getting namespace. So you can probably see that. There we go. It actually created the federation namespace. Okay, federation system namespace. And if I go to that namespace, and get pods. Oh, there's nothing there. Well, that's not good. Something needs to be there soon in order for this to work. So I'm gonna wait for that a little bit. Okay. So it will eventually complete. Oh, there we go. That was tough. All right. So here we have the API server and the controller manager, and other things will come up in a second. All right.
What's in Cube public?
Where?
The other namespace, Cube public. I haven't seen it before. Is that something that you guys, that Google does?
No, actually, I actually never seen that before either.
Okay.
Let me see what's inside.
So when it's the ingress controller, that's what I
It was
remember.
added in one of the recent releases, but I can't remember what it was for.
Yeah. Okay.
Yeah, no, there's nothing in there.
I've never seen it, and I'm like, what in the world?
No, I have not seen that either. Yeah, or I just never really paid attention to it. Yeah. All right. So, oh, there we go. Yay. Whew, that was close. All right. So we have the federation initialized. There was a service that was deployed as part of this. So if I go to get SVC, there we go. That's my federation API server. And this is now in my context. The name of this federation is what I put after init, right? So I say Kubefed init federation. That's the name of the federation. I can call this whatever I want, essentially. But this will ultimately affect how we generate the service discovery endpoints for the federation. All right? And what that also means is that now I have a context locally, co-federation, and I should be able to say get deployment. And now this is going to the federation server, and we should be able to see deployments across all of the clusters. I have none right now. What we should also be able to see is to see get cluster. These are just going to be the clusters that we have registered, which is there's nothing there right now either. So I'm going to go ahead and do a few cluster joins. Let me see here. Showing you guys. All right. So I'm going to join the federation. This is funny. It's a little funny. You have to join yourself into the federation too. Okay? Because the first command line we did is just run the controller, right? It has no context of its own cluster that it's running on. So you actually have to join yourself if you want this host cluster to also be controlled by the federation. And then we can join the other one. Let me see the other join, which is the EU West cluster. Okay. You do need to give it the context, right? That's locally to you, so we can send the information over to the API server, and that should be it. And then we should be able to say get cluster, and now we have two clusters being registered in federation. Now we have to wait for this to get ready now before I move on. Yeah.
So if I elected not to join the host cluster to the control
itself,
plane, to the control plane,
Yeah.
what are the ramifications of that, or when would I ever consider doing it?
If you wanted a cluster, if you just wanted to run the control plane just for the control plane's sake, that's what we looked at.
Right? Is that a good practice or just a different practice?
No, it depends, right? It's almost like if you want your master node to also run other workload kind of thing. Yeah. In most cases, I have seen people just join the same cluster because the cluster has a lot of resources already, so they can just join it. But if you have like a really small cluster, in which case it doesn't really matter if it's part of the federation that you want to manage. And also, remember, you can actually have multiple federations as well, right? Because here we said the Kubefed init, and we initialize one federation. You can actually initialize multiple federations if you want to. Yeah. So, for example, maybe you have different applications that you have to run across the world, and they run on different clusters. So maybe you want to have different federations for them as well. Okay. Yeah. All right. So let's see. Whew. Yeah, they're ready. That's good. Yeah, not bad. So now I can just deploy. Remember, I have the services and the deployments that I have. Let me do one thing. Well, first of all, let me go ahead and deploy the deployments. All right? And let me just check this. The export gives me a few other things I don't want, like creation timestamp. I don't really need it. Self-link, I don't want that either. Okay. And all right, that's not bad. So let's see. Just to being able to visualize this a little bit better, I am going to take these two visualizers Okay, so one of them is to the west. One of them is to the central region, and the other one is to Europe region. Okay, I don't know which one is which actually. I think the top is central, and the bottom is EU. And so I can go ahead and deploy, apply. And when I deploy this, I need to make sure I'm going to the federation, of course, and deployments. Oh, there we go. That's interesting. Namespace depot not found. Okay, so that is actually one of the most frequently occurring error for me in this demo, because even though we have a default namespace in each of the clusters, the federation does not understand this. The federation does not make any assumptions about what namespaces you have across the cluster. So you actually have to create this namespace in the federation, and that gets propagated. And if you already have it, then that's fine. If you don't, then it's going to be created for you. So namespaces is one of the things that you can federate across multiple clusters. So for that, I need to say create ns default. All right. So let me do the federation get again. Now I have the default namespace. If I create another namespace that's not existing on the other clusters, we'll just go ahead and create it. All right. So now I can go ahead and apply this deployment. And let's see. There will be a little lag in terms of getting to the API, the federation server first, and then subsequently getting to each individual clusters. Right. So I just deployed to the federation, the backend and the front end, directly into the two clusters. And now you can actually see somehow it decided to run the backend in US Central, and the front end is running in EU West, right? So they're actually running in different places right now, all right? That is fine, that is okay. We can fix that in a second. The other thing we can also apply is the service as well. So let me just see the service export, okay? There are a few other things we have to fix in here, particularly what I don't like is the self-link and the creation timestamp, which doesn't do anything. All right, but there's one other very important thing we need to get rid of is the cluster IP unknown. That doesn't mean anything either. One thing that is quite important in the service, potentially, is the node port. Okay. The reason why that's important is because for the most cases, if you ever want to put an ingress in front of your federated cluster, the only way for the ingress to get to individual pods or individual services is actually through the node port in this case. So I need this in particularly to be able to federate my cluster and be able to expose my services on the front end with the ingress, especially on the Google Cloud. Okay, so that's why the node port is actually quite important. You do actually want to specify it in this case. Okay, so let me go ahead and deploy that kubectl apply. Just make sure I got my context right. Federation. Apply my services channel. And that should get applied again across the clusters. Now in this case, I have done this to the federation, but my backend service is actually in both clusters now. It's just that in the EU cluster, it doesn't map to anything. Okay, there's no pods that's serving the service. Yeah, so it's just there in case you do deploy something that is accessible. Right. Now here's the tricky part. If I need to access my backend, my front end with the backend, what do I do? Let me see if I can exec into it. So I'm going to go into my US Central cluster. I got BusyBox running there. So Central is the one that has the backend, right? So what I should be able to do is to do a wget output to this and HTTP. The backend is hello world. Sorry, not hello world. Button matcher. Backend. It's probably on 8080 API next. Okay, so that works perfectly fine. All right, I'm on US Central. My backend is running in US Central. Great. Now, what happens if I try to access the front end? Any guesses? Anyone? Would it be routed magically to the other cluster? Yeah, it would be really awesome if it did, wouldn't it? But it doesn't. Yeah, So what happened here is that if you ping this IP address, this still go. If you ping this DNS name, it still goes to the local cluster IP, which is that, which has nothing, right? It has no backing services to it. Now, what I also have done in the services I demo is that I specify the type called load balancer. And we all know what that does, right? It actually exposes the load balancer via a public IP address, okay? This is actually necessary if you ever want to do cross-cluster load balancing. The question is, how is it, how is a pod inside of the cluster in Asia supposed to be able to talk to another service that's in the US, right? Without complicated networking, right, the simplest way to do it is by exposing the services publicly or on some higher level network as a single IP address, and it just go over that IP and just connect it to this service that's running somewhere else. Okay? And that's why for a cross load balance service, we have to expose it as a load balancer. And what that also means is that if I go back to my DNS name, let me see here, called DNS. If I got everything set up properly, there we go. We actually automatically create all of these DNS entries for you as well as part of Federation. What that means is if I need to get to the EU backend service, there's a very specific DNS name we can use. Okay. Same thing with the front end as well, right? Moreover, there's the let me see here. There's the default DNS name. So if you look at this carefully, it's actually a tree. The DNS name is actually a tree. You can start off by calling button match of backend. Well, what is that going to resolve? That's actually going to resolve to your cluster IP. But if you refer to the service with the federation DNS name, which will be the service name dot namespace dot name of the federation, then it will propagate this lookup. If there's nothing running locally, it's actually going to come to this external DNS server and figure out what is actually running there. Okay. Now, I'll show you one thing first before I go back to that. Right. So here we go again. If I go to wget o-q http button masher frontend 480, there's nothing. But if I put in the federation name, hopefully default federation, then me just get resolved automatically, right? It actually pointed me to the external IP in this case. Right? So I'm going to copy and paste that. I'm going to ping it, and that pings the external IP address. That's because there's nothing running locally. Now, what happens if I do run something locally? Let me see here. So I'm going to go ahead and expand my front end to both clusters now. So what I can do is I can do a context federation scale my deployment button masher front end replica front end, yeah, replica is equal to 2. Right. Now before I do it, just make sure you follow this closely. So there's the front end service. It doesn't map to anything. It has an IP address of 35.192, blah, 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 right? That's what should be in the DNS name. But if we go back to the DNS server, this lookup to the front end service only has one IP. It only has 35.195.18.221, okay? And that is actually the IP address of the cluster that has the front end running. So just keep in mind, the federation server is actually quite smart. It will only add the IP addresses that can actually serve traffic. Okay? In this case, this IP has no backing pods. That's why this IP address doesn't show up in the DNS name entries. Right? Now, if I actually go ahead and deploy this to replica is equal to 2, we apply anti-infinity by default. So it should say, okay, I need 2. I got 1 running in one of the cluster already. So eventually, this should end up in the cluster in the US. Right? Right now, it's running in the EU. Hopefully, eventually, it's going to end up in the US. All right, there we go. So now we have the bottom actual front end running in the US as well. and we got it running in the EU. And I can do the same thing with my backend. Backend, there we go, to replicas, right? And that will also propagate. But what's also interesting here is that if I go back to my DNS entries and refresh, check this out. This is so cool. Now my front end is running in both clusters. We got two load balanced IP addresses. They automatically get added into the DNS entries as well. Okay. Now here's the tricky part. You might say, well, hold on a second. Well, that's awesome because the DNS entries, now we can do round robin DNS entries. Yes. Some DNS server allows you to do that. In some cases, they don't. Then you still have to be careful, right? So now, if I go back to my BusyBox, no, not that one. BusyBox. Is that the one? No. BusyBox. There we go. All right. So remember what I did when I did the ping? I pinged this IP federation, right? So if I do the ping again, because I have this running locally, it automatically resolves to the local IP. All right. Now you gotta still be very careful here because not every consumer will respect the TTL nicely. Also, the time it gets to be updated, like the TTL is set to, like, I don't know, 15 minutes or something like that. It's pretty long for this type of use cases. So if your cluster does go down and your application has the DNS entry, cached to an external IP address already, you have to wait for this DNS entry to expire based on the TTL. And in Java particularly, sometimes they don't respect it well, so you gotta be careful, okay? But that's the gist of how you can use Kubernetes Federation to do cross-cluster load balancing, all right? Now, what would be really cool though is to actually run this in 3 clusters. I have that up and running somewhere. Where is it? There we go. All right. So you can actually go to here with your cell phones or your laptop, and if you click on the requests, you should be able to see that show up. Okay, so I don't know how fast I can click. There we go. 7 QPS. Oh, never mind. Yeah. So again, this application is deployed across in a federation across 3 clusters now. I have a cluster in Asia, in the EU, and in the US. All right. And I only have 1 instance running right now, and this instance is running in the US. Right. What we can do is to potentially scale it. But before I do scale it, let me go ahead and scale out with the load tester as well. So this context is actually code. What is it called? Oh man, Federation cluster, I think. Get deployments. Right? Yeah, I see some people. And sometimes what ends up happening is somebody has a laptop, they scripted it, and so they generate like 100 QPS per second, which is pretty decent over some Wi-Fi. But so I'm going to spin up my load bots. All right. So for that, I can go to my federation. I'm going to scale my deployment of my load bots. There we go. Replicas equal to 3. So what that actually means is I should be deploying a load bot instance in each of the region, each of the cluster. Each of the instance is supposed to generate 1,000 QPS at this moment. All right. So when everything gets spun up, I should see 3,000 QPS in total. Now, because I only have the backend running in the US, it's actually using the mechanism I just described to you. If I open up the loader deployment YAML, it's using the federated DNS name, right? And in this case, my federation is called Hybrid Cloud Rocks. Right? And because of that, all this traffic is being sent to the US. And I can, of course, scale my backend in this case. So I'm going to scale my Bottom backend to maybe 6 replicas. So I can do that. All right. And again, it's going to take some time to show up. But what we should be able to see is that the traffic is split across the 3 regions as well. Right. So here we go, 4, 5, 6. And the load bot themselves, they expire themselves. So they die after 15 seconds, they come back, they do the DNS entry query again. And you can just see that now you have about 2 backend instances running in each of the cluster. So the lobot, as the consumer, now goes only to their own backend that's running regionally. So they don't have to go across the ocean to get to it. Pretty cool? Yeah? All right, something even cooler. Of course, all of the same rules apply. I can also do my rolling updates across the federation. So there we go. I can go ahead and edit my deployment. This is my favorite way of deploying production application. Don't do it. But I'm going to just do that and update my workload. And again, this is all managed by the federation control plane. It's going to do the rolling update in each individual server as well. And there you go, bringing down one pod and starting a new one, right? And it's gonna, oh wow, it's done already. Seriously? Oh, there you go. Yeah. So now if you press, now you're seeing V2 instead. Just to show you what's actually running in each of the clusters. Let me see. So if I go to GCP US Central 1, let me see here, get deployment. There we go. Where is it? There you go. So all of these deployments and services are actually created directly from the federation control plane. I didn't do this myself at all. Right? All of these were propagated by the federation. Now here's one other thing that's really interesting. Suppose you do have 3 clusters in this case running, right? I have 3 clusters running, and you want to load balance your traffic from the ingress directly. What that means is I don't want just my internal consumers to use the internal service lookup to load balance my request. What I really want is to have the users, the end users, being served directly from the cluster that's closest to them. With that, it depends on the cloud that you're using. So for example, if you're on another web services cloud, you may end up using GeoDNS, right? So you need to have these individual EOBs or AOBs exposed with a CNAME of some sort, and then you gotta use the GeoDNS so that when the user from Asia does the DNS lookup, you give them the IP address for Asia, right? Now in Google Cloud, when we do create this ingress, which I have the ingress created as well. Let me see here. Is that the right one? No. So I should show the ingress context is equal to federation cluster get ingress. Okay. So this ingress, which was created from the same ingress YAML file, where is it? Button actually ingress, right? Pretty much a standard ingress. The only thing that's different is that I added an annotation here. That's only because I want a static IP address. I don't want my ingress IP to change over time. So that's very specific to Google Cloud. If you want a static IP, you can reference that static IP name basically by name. So I created a static IP array, and every time I create this ingress, it's going to use that IP address instead. But when I do create this ingress, what that's going to do is to create a global load balancer in this case with a single IP address on Google Cloud Platform that can be accessed from anywhere in the world, so you don't have to deal with GeoDNS at all, and you will still be able to route traffic to the closest data center to serve the user. This is actually quite incredible. The internal name for it is so cool. It's called maglev, like magnetic levitation or something. I have no idea what it means. Like why is it called maglev? But there's a public paper you can read about how we do some of these things. But that's the type of load balancing technology that we can use. And what that also means is that if I go and let me see here, where's our backend? I need to. It's called hybrid. Sorry, I need to find out backend first. It's called hybridcloudrocks.com. No, that's the stack. That one. No. So all right, let me change my thing. So I do have the backend here. It's called API Next, right? All right. So what I can do is to edit my my lobot. Cool. Yeah. All right. So where is it? Edit my deployment. Lobot, I believe, and this is running in Federation-cluster. Okay. what I want to do is to, rather than using that, I want to use what is that? hcr.ks.io, which maps to my my ingress IP address. I'm going to hit it on port 80, just 80, not 8080 anymore, on that API endpoint. All right, let's see if that works. All right, so again, I'm using Federation to propagate out my new configuration. So pretty soon, hopefully my load box is going to change their configuration. And rather than calling the internal DNS names, it's actually going to go out and use the public IP and the public ingress, right? And what that also means is that if I come back here, like, I don't know what happened, but, you know, it worked. All right, so anyways, I have my cluster up and running. All my traffic is directed via the ingress. And for some reason, I think my load bot is only running 2 regions right now because of the rolling update. It ended up in 2 regions. I can scale this up a little bit so it runs in Asia too. So give me 1 second. Oh boy, that was close. But I'm happy we had a good workaround for this. All right, let me go up to 6,000 PPS. All right, so it should also generate some load from Asia. All right, so now this is actually going through my ingress. And what that also means is I can actually see it. If I go to my networking services, I just show you a quick thing about load balancing on Google Cloud. If I go to my ingress, is that? Yeah, that's the right one. Is that? No, that's not the right one. Let me see here. I need to go to my project. Everything in Google Cloud is organizing a project. It doesn't matter which zone your machine is running on, they're all in the same project. See everything in the same view. So this is our DNS, this is our ingress, it's our global HTTP, HTTPS load balancer. All the ingress mapping is already done here. And they do actually get mapped eventually to the node port. That's why node port is important. So for example, my my application is running on 32081, is that right? I suppose. And if I go back to my backends, monitoring, there we go. This is pretty cool. And so you can see all the QPS is coming through. I should ultimately see 3,000 and then 6,000 QPS. It's a little delayed, a little behind. But if I go to my backend, like that one, there we go. This is pretty cool, right? So for some reason, my North American traffic all got directed to US Central, European traffic all directed to European cluster. And my Asian traffic, for some reason, got directed to US and the EU. And that's because my backend there is failing for some reason. So our health check is actually picking this up and said, you know, hey, wait a second, don't route any traffic to Asia because you have issues. So just go ahead and route it to another zone instead. All right. So that's pretty much a lot of things about Federation, the basics. There are some more advanced annotation you can use to specify what zones or which cluster you want to have the deployment to be pinged to. The annotation is quite, involved. That's why I'm not gonna show it today, but you can find it in our documentation as well. Okay. So with that, all that said, let me see if I have anything else. I think I covered just about everything. Now, if you actually want to try some of these things out, I do have the application that you can just download in Bootstrap. I have everything scripted. You can bootstrap a Federation cluster with exactly the same demo I just did, and that is under my GitHub, Stalinism, and it's under the Federation example. Okay, so that will be the 1, 2, 3, 4, the 5th link or the 4th link there. I always get asked this question, like, what did you use for visualization? Because that was pretty cool. And that is an open source project that was actually originally created by Brendan Burns. And I added a few things to it because I wanted to show the nodes in addition to the workload. The reason I wanted to do that is because I actually have a Raspberry Pi cluster running Kubernetes as well. And I demoed that about 2 years ago. Apparently, this is a trend now. Like every time you want to learn Kubernetes, you gotta get Raspberry Pi first. So I'm very happy to be one of the person behind it. So you can find some of those things in my blog as well. And I actually have a collab online, and the collab towards the end is actually setting up a federation. So you can try that out too. All right, you do have to get your own DNS name, but aside from that, the steps are pretty straightforward. All right, so I think that's all the time that we have, and thank you very much for your time. I really appreciate it. Yeah.
So I know that there are certain resource types that are not yet, or may never actually go across federations.
Right.
But so let's say let's talk about secrets, config maps.
Maps, yeah. Namespace, deployment, replica set, and service.
So stateful sets are not there.
I don't think that's there, and also it would be maybe a little dangerous to have.
Yeah,
as well. Yeah.
And then how about your volume, your persistent volume claims and all that stuff? How does that work?
I don't think there is a federation for those either. So you may end up needing to create your own PV first, and then PVC, but then your deployment should just point to the PVC instead. That's probably the easiest way. Yeah. Yeah. Question?
So if you edit something, for instance, set the number of replicas in one of the subclusters, is that going to get respected or
I see. So for example, if you get deployment in one of these things, let me see here, context is equal to, I don't know, GCP West 1. I could never remember my context names. It's so annoying. Did I use Europe or did I use, oh my God, all right. There we go, I got it, yeah. I think I got it. Yeah, there we go. Yeah, so if you actually modify one of these things, the federation controller has a reconciliation loop. So it's going to say, wait a second, sync. And so you actually adjust it back to what the federation wants. Yeah. So like if you make any things manually in the cluster, it doesn't really, I mean, it will take effect for a few seconds. I mean, I tried this myself and ultimately gets overwritten by the federation.
What if different clusters have different capacity and you got one really big one and a couple smaller ones and you don't need 6 replicas?
Yes.
or my question is kind of the same, you know, that Asia's got a lot more traffic than Europe, so you want things to be scaled bigger.
Yes, so for that you can use weights. So in the annotations, there will be an annotation where you say, you can actually control the minimum instances, if I recall correctly, the minimum replicas in the cluster, and then you can have ratio, like a rate, like this cluster is 80% in terms of all the pods that should be there, right? So if you have a bigger cluster, you should give it a bigger ratio, bigger weight, basically. Yeah, so that's actually configurable in Federation. Yeah.
What's the normal, I mean, so it seems to me that really Federation, its key use is regional change. You could just, you know, make a cluster that, you know, with nodes span multiple AZs and kind of have full support for pretty much all of the features. And is that right? It seems like Federation is really like region. This is how you do regions with one plane.
I would say that in my mind, it will be a way for you to control clusters that has high latency in between it, right? Typically, between AZs in the same region, the latency is really low. Specifically, like on Google Cloud, it's almost like you cannot really perceive it in a way, right? So that's why when you create a cluster with us, for example, I just show you this very quickly. If I were to go and create a cluster, create a new cluster, you can pick and choose the primary region that you want to run on. But towards the end, let's see here, more. You can also specify additional zones as well. And if you do it this way, right, you just got multi-zone, like highly redundant cluster in one click. But if you do want to go across region, in this case, would be you have higher latency. The egress cost is also higher. Then you do actually want to use Federation. I think most part, Federation right now is really good for provisioning. So if you need to provision your pods across multiple clusters to serve traffic from the closest region possible, you can use Federation for that.
Okay.
For server discovery, I would say it's a little, you know, you got to be careful.
A lot of public IPs, right?
Yeah.
Like if every service gets its own public IP, like you don't have a lot of them.
Yeah, exactly. Yeah, exactly. But what will be really interesting is to see this work with internal load balancing, right? So in Kubernetes, you can also provision internal load balancers. They act like an external load balancer, except you have internal IPs. But that is not a cluster IP. It's really confusing, isn't it? You have the cluster IP that's a bit on the machine, And then you have the internal LB, that's the external IP, but only accessible from within the internal network. And then you have load balancer IP, which is a fully external IP that's accessible anywhere from the world. So I haven't tried this myself, but what I really like to see is to have this with the internal load balancing, because that's going to give me an internal IP that I should be able to access within my Google Cloud project, and that should be it. That should be really it. Yeah. And to get the internal load balancer, you gotta use an annotation. So it's gonna have the type of load balancer, but with the annotation of internal load balancer. Yeah. That'll be really interesting to try. I'm gonna try that later after this talk. Yeah. Or something that's not recorded, because I have no idea how it's going to work out. Any other questions? Yeah.
So is you have 164 as the default that's on Google.
Let me see here. 167.
167, sorry.
And you can pick and choose as well.
What would you consider would be the best version to start in a production world for Federation? Because like KubeCon last year was kind of like, yeah, it's not quite production. So is 1.7 where you think that the stability is for a production federated cluster environment would be?
I have to say definitely not 1.5. Because I tried 1.5 before and it was not easy to do.
Yeah.
And it was a little flaky. 1.6 has been very stable for me. What is also interesting is the Federation API server version. It's not so much of the cluster version, but it's the Federation API service version. So for example, I remember 1.7.1 was a little flaky when I tried my Federation cluster. It did not work well because it didn't work well with the cluster settings I have. So that was flaky. I found 1.6 to be one of the most stable ones for what I need to do. But that's just my preference right now. That's also why I haven't upgraded to 1.7, because I don't know what's going to happen if I do. For now, I will eventually get it. So from my experience right now, I say 1.6 is pretty good. 1.7, the latest 1.7 is probably just going to be better. But there is just one specific version that I'm using right now. Yeah. I know there's a question in the back. I want to show another thing as well. Yeah.
I was just curious how many times you've given this, because that was the best demo I've ever seen.
It was all recorded.
Yeah, again, I was just moving my hand on the keyboard. I wasn't exactly thanks. I really appreciate it. This is probably my second time to actually, federate a cluster live in front of audience. Now, before 1.6, I would not do this, right? 1.5 is, again, it's a little flaky, but 1.6 is actually pretty stable for me to be comfortable enough to do this in such a short time. So yeah, it's pretty nice. One thing I forgot to mention, since we are all still here, let me show you one really cool thing. Namespace is equal to kube system. What the kubefed command line actually does behind the scenes. Did I get this wrong again? Yeah, I did. Sorry. I need to redo all of these things in the future. All right, short. Yeah, exactly. I need to keep it shorter. All right, so you all know that we have kubedns running somewhere, right? So here's the kubedns that's running instead of the kube systems. The way that the Federation DNS lookup works is that we actually configure kubedns to be Federation aware. Okay. It used to be a manual process, but now with kubefed, what they did behind the scenes is that they added a config map for kubedns. If we open up this config map behind the scenes, yeah. If I scroll down, where did it go? What? No. Wait, did I not see the right one? Oh, there we go. Ooh. Yeah. So there's the data. So that's how this gets tied up eventually. Basically, that's how we determine, servers.default.hybrid cloud rocks will need to ultimately resolve, from this DNS suffix. That's pretty much how it works behind the scenes.
Does core DNS have the same?
Yes, core DNS, the last time I checked, has the similar functionality. So when you do create your provider, when you do the kubefed init, there we go. the DNS provider, you would need to use something else. In your case, it would be core DNS provider. Oh, and one last thing, just so if you ever want to try it, the DNS zone name is very, very important, right? Because that determines basically what DNS, ultimately the DNS suffix you're going to be using. Now notice here, notice this tiny thing here. Like there's a dot behind this DNS name. That is not there by accident. If you miss it, you're gonna be pinging me at 2 a.m. in the morning, and you probably already spent 2 hours trying to figure out why Federation didn't work. I'm going to tell you it's probably because you missed the dot, and you're gonna say that's probably what I did. So keep that in mind, because that's what happened to my coworkers. One of them did the live demo on the Federation too, but, and yes, one of them missed the dot, and and that didn't work so well. The dot is necessary until they fix the command line, which I don't know when. All right, cool. Yeah. Any other questions? Was that pretty useful?
Very nice. Yes.
Yeah. Anyone here needs Federation or are looking to Federation? All right, cool. Yeah, please reach out. And one of the reasons I'm here is so that I want to get community interested and participate in the community. Join the Slack channel, join the forums, and help us to make this better. All right, cool. Thank you.
So if you come from New York and present,
Ooh.
you get a gift. You get a gift from Ancestry.
Really?
DNA,
Oh, that is so
a
cool.
DNA kit, and then also
Really?
a year of free subscription to Ancestry. So
Wow, that is so cool.
So thank you.
Thank you so much. I really appreciate it.
Appreciate you coming.
Thank you.
Again.
Yeah. All right.
Actually, I have another question.
Yeah.
As far as use case.